We classify drugs in one of four categories: narcotics, depressants, stimulants, and hallucinogens. Now, these are ones that really affect us in law enforcement and forensics because these are examples of drugs that can be abused. There are other drugs medically that we don't classify in this, but we're going for these four definitions. Narcotics are going to be drugs that are analgesic, so they cause a depressive response in the central nervous system and they relieve pain. We will see that there is a physical response of lowering blood pressure, lowering pulse, lowering breathing rate. We're seeing a depression on what the body normally does. So we'll see less activity. And again, CNS stands for central nervous system. And we do definitely have a physical dependence with narcotics. Narcotics are basically going to be an opium or an opium derivative. What do we mean by that? So opium is a plant, well, poppy is a plant, and the seeds of the poppy create a resin that we call opium. Opium can be smoked directly and taken directly, or we can take things and extract different chemicals that are part of opium. One part of opium is morphine. So about 15%, up to 15% of opium actually is morphine. So we can extract morphine and out of opium and just use the morphine directly. And we notice that definitely because of the depression of the nerve system that controls our eyes, you see very constricted pupils. Constricted meaning very tiny little pupils. You see big irises, tiny little pupils. And it is an anesthesia that doesn't decrease consciousness. So in other words, you can be numb to the pain, but still be conscious and present, versus other ones where it sedates you to the point where you're not conscious. Codeine is another component of opium. Technically, you can also take morphine and do chemical reactions to it and produce codeine. So there's two ways to get codeine. And it depresses cough. So that's been used in a lot of cough medicines in the past and even in present in prescription use. So along with also depressing the central nervous system and having a lowered effect of breathing and blood pressure, it also can depress cough. It sort of weakens the lungs' response to irritation, and so you don't cough as much. Heroin, similarly, is a chemical that is made from morphine. So it's not a natural product. We have to make heroin from morphine, but it's not particularly challenging. And it is a solid that's often, you can turn it into liquid by a little bit of heating. It doesn't take much to heat it to a liquid, and then inject it. It produces a very feeling of euphoria, and it's drowsiness, but a very relaxed state for a few hours, and it is heavily addictive. Then we have synthetic opiates. These are ones that I can't make from opium, but it turns out they act very similar to opium because they have a similar chemical structure. OxyContin, methadone, Demerol, and fentanyl are examples of synthetic opiates. So OxyContin is, again, not derived from opium or morphine, but we're going to see very similar effects because it is similar in chemical structure. And it's often used as a chronic pain management medicine, but it's also heavily addictive. Methadone is another one. It's been related to heroin, and it is one that helps with the withdrawal symptoms from heroin, but it still is an opiate derivative as well. So it's controversial in using it as a step-down drug to withdraw from heroin. So we see in general, this is a chemistry class, we're going to do a little bit of chemistry. One of the things is that similar drugs are going to have similar chemical structures. So when I find two drugs with a very similar chemical structure, I expect that they're going to have similar effects on the body. And that becomes helpful, especially when people create new designer and synthetic drugs. I can kind of make an expectation if I know what the structure is, if I can derive the structure using some analytical tests. So notice most of these have this 6-membered ring with these extra lines in it, and then another 6-membered ring next to it, and then a ring with an O, and then another ring, and then this sort of chain and an N and a CH3. So we have that same pattern here. We have that same pattern here. Ring, ring, O-ring, another bent ring, a line with a nitrogen and a CH3. Here we have almost the same, a little bit different. Notice that now these two rings are not combined, and that ring with the oxygen is now a little bit opened up, and I have an extra ring here, so it's a little bit different. And then I have fentanyl, which looks pretty different. But most of these are ones where there's only a slight bit of change. Now here I'm missing that inner ring. Here I've got some extra stuff on the sides. Here I've got these on the sides. So there's a little bit of changes, but they're very similar. And so I expect to have very similar reactions and chemical behavior in the body. We also have a ton of street names for opiates. I leave this document for you to click on and look at. This is one that kind of goes through many, many names. Of course, there's many prescription drugs that are in the opiate family, and there's many street drugs that use opiates. Depressants are then examples of another class of drug, and these are ones that tend to depress the function of the central nervous system. So similar to narcotics, but they're not opiate derived, and they don't have quite the same, they don't have the analgesic or pain reducing quality that narcotics have. They do calm irritability, and they can relax people. So people who are very anxious, it may help with sleep patterns. Alcohol is an example of a depressant. Barbiturates, we have a lot of psychological anti-anxiety drugs. Also things that tend to be huffed and sniffed. Airplane glue, model cement, aerosol, gas propellants are all examples of things that are also depressants. So we're going to see a similar feature of depressing the breathing rate, the pulse rate, and seeing a lowering of bodily functions. So we know that alcohol will enter the body's bloodstream through the stomach and then quickly travel to the brain. We notice that we have relaxed functioning of thought processes and muscle coordination. And then we have barbiturates, often called downers as well. These are pills generally, a feeling of relaxedness and well-being, and helps with sleep. We have anti-anxiety drugs that are relaxing without changing the ability to think or sleep. So Valium and Xanax are examples where they don't induce sleep and can continue with sort of mental functions, but do relax the body. And then we have sniffing, which can have that same sort of effect of relaxing, but has an awful lot of very acute effects on liver, heart, and brain damage. And so it's a particularly dangerous kind of drug. Stimulants then, we have ones that are the opposite of a depressant. It's going to accelerate the body's functions. So we're going to see increased metabolism, increased heart rate, increased activity and mental alertness. These are often taken for waking up, alertness, or activity. Also for loss of appetite. These have been traditionally used for diet drugs. They're kind of addictive, so it turns out that's not so wonderful for losing appetite. It comes at a cost. So amphetamines, uppers, speed, cocaine, crack are all examples of stimulants. So when we have amphetamine and methamphetamine can be injected, have a intense feeling of pressure followed by exhaustion and then prolonged depression. So many times we see this sort of opposite effect. After the initial high, we see a big crash. Similarly with depressants, you can see a lowering, a relaxation followed by an over alertness as the body tries to respond and fix the problems that's happening. So if you put the body on alertness and increase the activity, the body is going to respond by trying to relax that activity, and that's where that crash comes afterwards. Cocaine, of course, is extracted from the coca plant, and often it can be snorted. It can also be turned into crack, where it's now can be heated and smoked. So two similar, crack and cocaine are basically the same compound, just in different forms and taken in different methods. And the final class of drugs is hallucinogens. So marijuana being the most widely used hallucinogen. Marijuana can actually be classified in other dimensions as well, but we're going to classify it as a hallucinogen. It causes marked changes in the thought pattern, perceptions, and moods. So it's sort of very effective in the affecting the brain and how we perceive our environment and how we respond to it, sensory. Again, marijuana is the one that's probably the most controversial. There's a lot of ongoing research. Our book is a little bit outdated in terms of the current state of research on cannabis. So marijuana comes from the cannabis plant. Its main active ingredient as far as producing a high effect and the hallucinogenic effect is the THC, and that's the one that's causing that sort of psychoactive effects. It also has CBD in it. I'm sure you've heard of CBD oils, so that's another component of it. A lot of the research at this point is not conclusive because as you do psychological effect testing, it's very difficult to measure it. So there's a lot of controversy in here. And of course, the legality of it is changing very rapidly as some states introduce and make it partially legal or medically legal. So this is something that's definitely in flux, and our book is a little bit outdated. But we're going to go with what our book says, and we're going to classify it as a hallucinogen. Again, we say that it's basically the main substance that's responsible for its effects, hallucinogenic effects, is THC. And we definitely see the THC content level is going to be highest in the resin. And the resin can be, talked about as being hashish, is the form of the cannabis that has the highest concentration of THC. And then the flowers and leaves have less THC, a little bit less in the stems, roots, and seeds. It is not a physical dependency drug, but there still is harm in heavy long-term use. There's harm with especially if it's smoked, with lung damage, there's harm. There are still issues, and there's concern that use by young users can damage development. Other hallucinogens besides the marijuana are LSD, mescaline, PCP, psilocybin, and MDMA, otherwise known as ecstasy. So LSD is a synthesized drug, very severe hallucinations that can last for a long time, for 12 hours. It's a fairly long time activity for a drug. Phencyclidine, or PCP, is generally also a synthetic drug that's made in a lab, and it can be taken in a variety of ways, smoked, ingested, or sniffed. It is frequently mixed with other drugs, sometimes with LSD to have two drugs, or with an amphetamine. It can be sold as, it's also referred to as angel dust. It can be in different formats. It can first lead to feelings of strength and invulnerability. This is the sort of the Superman drug. Many times people report, cases where people think that they can fly and they jump off buildings. Has a very strong sense of taking over the brain and being able to, experience an alternate reality that may lead to, and then the crash afterwards can lead to depression, suicidal tendencies, sometimes violence.